Now let us talk about the speed and velocity. Speed is the word that we use in common day-to-day language, and it refers to the distance traveled per unit time. The distance traveled by the body in unit time. Its unit of measurement is meter per second, and the speed is, of course, a scalar quantity. Distance is a scalar quantity. Speed is also a scalar quantity. But velocity is a technical term defined in physics, which refers to the displacement of the particle per unit time. It is a vector quantity, and its direction is same as that of displacement. For example, a particle starts from some point A and goes to some other point B following a particular path. Then the displacement is, as we know, the shortest distance between the starting and the final position, and displacement direction is always from initial point towards the final point. So in this case, it is the displacement vector. So direction of velocity will also be in the same direction, and it will be the direction of average velocity, because from A to B motion, this is the total displacement, net displacement, and total displacement divided by this time interval will be the average velocity for this interval. But velocity can be defined for each instant also. As I told you in essential maths for physics, that instantaneous rate of change of y with respect to x can be defined. That means if suppose y is some quantity dependent on x, then we can find the instantaneous rate of change of y with respect to x at any point of x. That we have already learned that how to calculate it, and that is basically the derivative of y with respect to x, and it is written as dy over dx like this. Alright. So in this case, you can say that displacement is a function of time. So time rate of change of displacement will be defined as velocity of the particle. Alright. Displacement is a vector quantity. So velocity is also a vector quantity, and instantaneous velocity can be defined. And in a particular path, suppose particle is moving along this path, then at any instant of time, the instantaneous velocity of the particle is always along the tangent to the path at that point. Means when the object was crossing this location, its velocity must have been this way. Or we can say that suppose at any instant of time particle was here, then along the tangent to the curve, this particular direction will be the direction of velocity when the particle was here. So instantaneous velocity is always along the tangent to the path. Instantaneous velocity is always along the tangent to the path. And this is the important point that you should always remember, that particle's velocity is always along the tangent. Alright. So instantaneous displacement is also along the tangent. And one thing more here I would like to add, that magnitude of instantaneous velocity. The magnitude of instantaneous velocity will refer to the instantaneous speed. Alright. Magnitude of instantaneous velocity is same as instantaneous speed. Magnitude of instantaneous velocity is same as instantaneous speed. Alright, because for a particular point, there is no difference between the magnitude of velocity and the speed. The difference comes or may come when it is a case of some interval of motion. And one more thing, as we know that displacement is what? The shortest distance. That is why we can say that distance is always greater than or at the most equal to displacement. So the same kind of relation can be written for the speed and velocity also. So let's move on to understand the speed and velocity concept with the help of some examples. There are actually three particles, A, B and C, which are not visible at this point of time, but I explain you prior to. So here it is one path along which the particle has to move. This is the initial point and this is the final point. And this is the second path along which the particle is to move, and this one is the third path. So this one is the straight path, and these two paths are some part of the circle. Alright. So the motion of these three particles are as like this. The particle A starts from this location and reaches here in time 3.2 seconds. Alright. And then particle B starts and reaches the point B at time 4 seconds. Alright. After 4 seconds. And then the particle C starts from initial point and reaches the final point in 4.8 seconds. So here it is given that these two segments are equal to capital R. Means the distance between this point and this point is equal to R, and here also. And as I told that these two paths are the part of a circle. So in all the three cases, we have to find the speed and velocity for the particle. So for speed, we need to calculate the distance, the actual length of the path, and for calculation of velocity, what we require? We require the shortest distance between initial point and the final point. So there are three possibilities of the path. One is this, and second path is this, and the third path is here. So let's assume that this is first path, and here it is the second, and this is the third part. And these are the two part of some circle. As it is clear from here that these two lines are mutually perpendicular. Alright, these two lines are mutually perpendicular, and it is R and it is R. So this part, particularly the part 3, this particular part is just a quarter circle, as you can see that, and its radius is equal to R under root 2. That you can understand easily, because this angle is 45 degree. Alright, this angle is 45 degree. So this distance is given to be R, and this has to be R. So it is R under root 2. So this third path is just a quarter circle of radius R root 2, and first path is half the circle of radius R. Alright. So length of the paths that we can easily calculate, length of path 1 is equal to what? Half the circumference, and radius of this path is capital R. So it becomes 2 pi R upon 2, means pi into R. So pi R will be the length of the path 1. R is given to be 100 meter. So it becomes 3.14 into 100. So 31.4 meter. 31.4 meter is the length of the path 1, and length of path 2 is clearly 200 meter. It is R and R, 2R. And similarly, length of path 3. Length of path 3 will be what? It is just a quarter circle, so 1/4 of the circumference. That means it is equal to 1/4 of the circumference of this circle. And radius of this circle is R root 2. So circumference becomes 2 pi R root 2. So length of the path 3 becomes what? Pi into R divided by under root 2. As you can see that 2 and here 2. So under root 2 is remaining at the denominator. So this is the length of the path 3. So if we want to calculate the speed, then speed of the particle A will be equal to, particle A is moving along the path 1. So distance traveled is 31.4, and divided by the time taken by the particle is 3.2 seconds. So we can calculate that. And similarly, speed of the particle B. Particle B moves by a distance of 200 meter, and that is within 4 seconds. So its velocity will be 50 meter per second. And speed of the particle C will be, length of the path is pi R upon root 2. Alright. Pi R upon root 2 means R is 100. So it becomes 31.4 divided by under root 2. So length of the path is 31.4 divided by root 2, and time taken by this particle to complete its motion is 4.8 seconds. So we can calculate this also. So you can find the speed using the length of path, because we are using distance traveled by the particle. And in all three cases, as you can see, that displacement is same, and it is equal to 2R. Whether the particle moves along the path 1 or the 2 or the 3, in all three cases, the displacement of the particle is just 2R. But time taken is different, so velocity will be different. So velocity of the particles in case of A, for A, velocity will be what? 200 meter is the displacement, divided by time is 3.2. And for particle B, velocity will be 200 meter is the displacement, divided by time taken is 4. And for particle C, 200 meter is the displacement, and 4.8 second is the time taken by the particle to complete the motion. So this way we can find the velocity of these three particles and the speeds of these three particles using the distance and displacement accordingly. I hope you have understood this particular example.